This is the first session on film masking, and this is the session that is probably new to most people watching this video, although there are people that have done masking. It's seldom taught anymore. I was talking to John Sexton, and he does teach this. He's been teaching for a while, but you know, most people don't do film masking, and they may not know about it. But everything I've taught thus far in the first two sessions was in preparation for this one. And actually this part of session 3 you don't really need to watch, because it's a history, it's a background of how film masking came to be. And this is the part where I talk about color, because film masking was devised for color photography, interestingly enough. And I did it for color for many years in my business, but now I do it exclusively for black and white. And and one of the reasons why I wanted to go into the historical aspect of this is because I wanted to pay tribute to the people at Eastman Kodak. I think George Eastman must have hired the best people in his time to help him build a company that became Kodak. I found this book. It's by D.A. Spencer. It's called Color Photography in Practice. And I picked up this book in 1972. I know this because I was 21. Actually, it's 1973. I was 21. Memory. In 1973, I turned 21, and I went to Hong Kong for 4 months to improve my Cantonese. I wanted to relearn the language of my youth. Anyway, I went to Hong Kong and I found this book, and it's written by a number of people who worked for Eastman Kodak at the time. D.A. Spencer was the head of the, I guess, this, and this book is a pirated version. I can see this Chinese text here. So it was published in 1970 as a second edition to Mr. Spencer's book, and he updated it because so many changes had been done in color photography by 1970. And it's got so much stuff in it. I've tried to read it a number of times. I would read certain sections and read it again and again and again, because I'm not a physicist. I didn't study this stuff. I studied music in school, so this is all was very new to me. But I finally read the whole book a couple of times, and I still don't understand the bulk of it, but I get the gist of it. And I wanted to pay tribute to these people who were such pioneers of the photo industry, that they would write so knowingly of this subject. But in any case, from this book I learned more about masking after I learned masking by the seat of my pants. But because I had this book, I referred to it when I developed a tri-mask method for making 3 colored exposures onto color negative film and making negatives from transparencies. And I was able to share that with people who bought our software in the 80s. But anyway, so my hat's off to these guys at Eastman Kodak. They did a wonderful job. And according to this book, color photography began right away. As soon as black and white, the first black and white photograph was made in 1830s, there was already the theoretical basis for producing color images, photomechanically. So, a person named Thomas Young in 1801, he figured out that sunlight was broken down into a spectrum of colors, the largest sections being red, green, and blue. And you can see this when you shine sunlight through a prism. As the light bends through this prism, you can see this rainbow of colors. And red, green, and blue are the largest sections of that band of light. So he was able to project white light through filtered water. By placing colored water or liquid between glass, it created a filter. And by projecting red, green, and blue in mixtures against one another in a darkened room, he was able to produce a whole shade of hues. And when it was balanced just right, he could produce white from combinations of red, green, and blue. So the theory was already there in the very early 1800s on how to separate color and to produce a color image. The opposite of red is cyan, the opposite of green is magenta, and the opposite of blue is yellow. So you have the primary colors and you have the complementary colors. And the very first color photograph was done pretty early on, in 1860. Okay, so in the 1860s, Clerk Maxwell shot 3 separate negatives of a still life, and each negative was shot through a different colored filter, red, green, and blue. And these 3 negatives produced a black and white positive, and he was able to project that positive onto a white background in a darkened room. But when he projected these 3 positives, he projected through a red, green, and blue filter. So he was able to produce a color image for the first time when these 3 positive images projected through filters were registered one another on the screen. It was cumbersome, and in fact the filters in those days, of course, they weren't very narrow cutting filters. They weren't pure enough to produce good color, but it was a color image nevertheless. And the film in those days was mainly blue sensitive, so it wasn't sensitive to red. So the red reproduction wasn't accurate at all, but still he was able to produce enough of a semblance of red that, according to this, Clerk Maxwell's experiment succeeded by accident, since at that time, over 100 years ago, no photographic plates available were sensitive to the full visible spectrum. It was the imperfections of the filters and the unsuspected reflection of ultraviolet radiation by the reds to the original subject which enabled the demonstration to succeed as well as it did. So eventually they invented panchromatic film, which was sensitive to red, green, blue, and color reproduction became much better, obviously, at that point. But 1860s, he was able to produce a color photograph by projection. Again, he shot through a red filter, green filter, and a blue filter, 3 separate negatives, which produced 3 separate positives. And by putting them in a projector and projecting through filtered light, he was able to put the color back together. Now, that's called additive because you're adding color to one another to produce a full spectrum of color. Again, the opposite of red being cyan, the opposite of green being magenta, and the opposite of blue being yellow. You can do color reproduction with subtractive color, which is in our world called CMY. C cyan, M for magenta, Y being yellow. K is for black. So in inkjet technology, we print with CMYK inks, and we're producing color photographs by spitting ink onto paper in percentages to produce, again, a whole spectrum of color. So the basic premise of color reproduction, dating back to 1801, is still being used today, and it centers around how the human eye sees color, the cones that we have in our, in our eyes, which is all covered in this book. But in any case, this is important because you'll find out, like I had said in the introduction to these lessons, how I learned to color correct was through the basis of color reproduction, the separation of colors and how you put it back together, because you can't just throw colors together, as you'll see. Now, I set up this computer so that when I work in Photoshop, I can simulate how early color was produced, and I'll do that in a second. The last thing I want to say here is that there was a gentleman named Albert in 1898. He came up with the idea of film masking, 1898, and it wasn't put into practice until the 1930s, when these people at Eastman Kodak started to experiment with his theories, and lo and behold, they found that it worked. Now, that came about because in the reproduction of color, they found out that the pigments and the dyes used to produce a color photograph were inherently poor in reproducing all the colors, especially the cyan pigments that they used. The cyan had too much magenta in it. A pure cyan would reflect only cyan color, and it would absorb the colors, everything except green and blue, because green and blue in combination makes cyan. But we'll get back to that later. But those are the three individuals I wanted to mention that I gathered from this book in the very early years. The first one being Thomas Young, 1801, stated the theory about the separation of colors from white light and producing a whole rainbow of colors by percentages of each one of those three put back together. Clerk Maxwell, who produced red, green, and blue separation negatives from a still life, producing positive films from that and projecting again through red, green, and blue filters to put back into one image those three sets to produce a color projected negative, which I'll simulate here for you. And then lastly, and I don't even have last name. I don't even know if Albert is his last name or his first name, but it's mentioned that Albert in 1898 came up with film masking, not to enhance contrast, which it does, but as a solution to color correction. So masking was developed for color, not black and white, although you use black and white film for it. Okay? And now I'm going to set up the camera so that we can look at what I'm going to do in Photoshop. And hopefully color separation will make more sense when I demonstrate that, okay? And again, this is just a historical background on film masking and color reproduction. It's not necessary to watch this part if you want to just jump right into masking, okay? But I wanted to include it, okay? Okay, back. Okay, I've got the camera focused on this computer screen. And many years ago, I shot a picture of my daughter washing the dishes when she was about 2 years old, standing on a stool. And my granddaughter, I decided to use this picture of my granddaughter because it's got a good amount of color in here to reproduce. So this is a digital capture that my granddaughter, the grandmother of my granddaughter, shot because she remembered a picture of her daughter when she was only 2 years old. So this is my granddaughter washing dishes in a red dress. There's a bit of gray here, some blue here, some yellow, a little bit. Anyway, so I decided to use this as my demo. Plus, because I love my granddaughter so much too. That's also part of the reason. But anyway, here is a background in white. And I already produced these layers. But basically how I produced the layer is I shot this through a red filter, so to speak. And I can demonstrate that by just, if I just make a, this is so big, let's see. It's 110 inches. If I produce this and I fill it with red, and I grab this red, I put it on top of this, and I give it a certain opacity, then I can create a red filter image in Photoshop. So it's a very quick way to duplicate what was done by Clerk Maxwell. Okay, let's just get rid of this. And get rid of this. So that's the red filtered image, if you will. Then if you shoot it through, not that, I'm sorry. If you shoot it through a green filter and a blue filter, add back the red, then you get a color image. If I turn off this, turn this off, you get magenta. Turn this off, you get cyan. So cyan is the opposite of red. Turn the red back on. The opposite of green is magenta. So if I erase the green, you see magenta information. If I erase the blue, you'll get yellow. But it's not good color, but at least it's color. And it's because the filters are not good filters. I just used a red patch and pulled off some of the opacity. So obviously it's not good color, but it's a color image. And this is pretty close, I would think, to what they got in the 1860s through projecting. And to them, it was like a miracle, I guess, color reproduction. And this is only, what, 25 years after photography was born. Black and white images were born. Okay, so the question arises, let's talk about opposite colors. That's right, let's talk about opposite colors. So in here, I had also produced these opposite colors. So the opposite of red being cyan, opposite of green being magenta, opposite of yellow, blue being yellow. But it's not, because it's the opposite, it produces a negative. So I had to produce this here to give you, if you convert it back, so you get a color image again similar to that one if I was to turn this off. Turn these back on. This gets kind of technical, so I'm only doing this because it's interesting to me. So this is a red, green, and blue reproduction. This is a cyan, yellow, magenta reproduction. Again, if I turn off the yellow, because this is subtractive, it's showing you the opposite color because I inverted it. Let's see, what I should do is this. What I did was this. I don't blame you if you get a little confused at this point, but it's interesting to me. So if I did this, let's get rid of that, and I flattened it, discard the layers. Then I invert this. It becomes positive, okay? And then you get, so in any case, that's what I did. Now, the question is, how do you produce good color? What is going to be your basis? I'll go back to the other version here. Of what becomes the basis of good color? Well, good color, as it turns out, can be determined through the use of a grayscale, because gray has equal amounts of red, green, blue, cyan, yellow, magenta in it. In essence, a grayscale, if you include a grayscale in your scene when you photograph, and you print for this good color, equal amounts of red, green, and blue, these colors will then fall in line. So good color reproduction is a byproduct of good grayscale reproduction. And that's something that a lot of people don't strive for. Even if they know about it, they may not strive for it. You can't always have a grayscale in your scene. You're not going to shoot your masterpiece color photograph and stick a grayscale in the corner just so that, I mean, printers do that when they run posters and such. You'll notice that before the print job is cut, there's inevitably a grayscale and a color bar in the edge of the paper for the printer to check, make sure that everything, the registration and the color reproduction is staying in line. They have to modify the inks as it's being laid down on a printer. If they're running 10,000 copies or something, this is how they check and make sure that the aims and their color reproduction is accurate by looking at the grayscale. Okay, so this part here is what's so important, and that is how we devised our software around grayscale. We included a color on top so that you can see whether or not this particular manufacturer of films or papers had a better yellow, or this one had, but it was a grayscale that we relied on in our software when we made recommendations how to make a color negative back in the 1980s. Okay, so again, looking for neutrality then, even in colors, is how I color correct when I work in Photoshop or in a darkroom. When I was printing color negatives, you make color corrections. You test your image and you look at the colors and you adjust the enlarger so that you could come up with a better rendition of the color image that you're printing. And you always look for the grays. Now, I've never seen a truly beautiful color print, which is one of the reasons why I turned to black and white. As hard as black and white is, to many steps, color printing is good color printing is nearly impossible. I've never seen a color print as good as Mother Nature provides. I mean, all you have to do is walk up to a tree with green leaves, and it doesn't even matter what kind of lighting you have. If you walk up to it and you just stop and look at it, you will see so many shades of green in one tree. And the neutrality from the bark to inside the green, the grays that are in this green are luminous. And you can just stand there and look at 1,000 shades of green in one tree. I've never seen a photograph like that. It's very moving to be captivated by just the colors of the greens that you'll see. So anyway, look for the neutrality in colors. I'm afraid that the fashion now is to come up with strong colors, and people are jacking up colors, and they think that's good color, and I don't. But with Photoshop, you can do that. I mean, to do this in the darkroom in the 80s and the late 70s required film masking. In film masking, you're making films that would help you dodge during your exposure in perfect register. And by making 3 exposures onto your negative, you make a red exposure, green exposure, and blue exposure, balancing the gray, then you can have a balanced color neg through 3 exposures. The trick is to use a mask for the red exposure to block certain areas here while letting a neutral amount of exposure through here. So by switching black and white films during the red exposure, green exposure, and blue exposure, you can then enhance your colors. Well, you don't need to do that because you have Photoshop now, which allows you to do it easily enough. I mean, you can even go into here and just increase, make the yellows more bright or dark. You can see it doesn't affect us so much, but all the yellow information here. So Photoshop is amazing, but I'm not excited about Photoshop. I still like darkroom work, to be honest with you. After all those years of working in the darkroom and then switching to digital printing, in 1995, my lab started doing digital. Up to now, I'm still not cured of darkroom work, I guess. Okay, so this is how you determine what good color is, by looking for a good grayscale. Sidewalks, you'd be surprised. Metallic thing, you just look at those objects in a color photograph, even the granite of a mountain, how much neutrality you can get there. You know, quite often you'll see shades of color opposite one another, like a very strong magenta cloud and green shadows. Well, if you were to fix the shadows, the clouds will get worse. And so that's, in our industry, we call that crossover color. It's a bad negative that produces a print like that, okay? And that was one of the things that our software addressed. Okay, so that is the basis of color separation, color reproduction, and again, the reason why masking was invented was to correct color, because when you measure, let's just do this real quick. You can measure the color, in Photoshop it gives you a numeric readout. But for example, here's a red. Red is 190, green is 60, and blue is 62. So if you subtract 60 from everything, you'd get 130 red. Okay. Now ideally, if you were to do this on a densitometer, you would get 100, 0, 0. I mean, it would completely absorb green light and completely absorb blue light. So you would only get red. Well, in fact, it's not perfect. And any pigments and dyes that are used for the reproduction of color, when you do measure on a densitometer, there's failings. Here, the cyan patch is reading 86, 153 for green, and blue is 196. So none of the colors are pure enough to represent strictly just red, green, blue, cyan, yellow, magenta. There's failings, and it's failings in the pigments and the dyes that are used for color reproduction. And that's what masking addresses. Okay? All right, so let's switch back. Okay, it occurs to me that I mentioned film masking being devised for color correction, and I think I should give you an example. The example, actually. The cyan dyes and the cyan pigments, whether you use dyes or pigments, to make a print, contain too much magenta in there. Now, cyan is made up of green and blue. So ideally, it shouldn't have any color in there except green and blue. If it has any bit of magenta, it's going to degrade the green that's inherently in cyan. And throughout the years, as they try to make as pure color dyes as possible, they haven't been able to solve this problem. But initially, in the very beginning, you can see how much deficient these dyes are by using a densitometer and seeing how much red, green, and blue is reflected from the samples that you measure with this densitometer. So only one number should be high and the other two numbers should be low or non-existent. And that doesn't happen. And none of the colors are that pure, whether you measure red, green, blue, or cyan, yellow, magenta. So Albert thought of an ingenious way to fix this before 1900. And it wasn't tried until the 1930s. But when they tried it, this is what they did. Now, a mask, he proposed that you make a low contrast positive from one of the separations. So you take the red negative separation, it's a negative, and you sandwich that with another sheet of film and make a positive. At this point, you don't need a filter to do this because the red negative has already been filtered. So you just make a positive, a low contrast positive. And when that film is dry, that positive is not used with the red separation, it's used with the green. So you're not allowing the green to go into certain red areas, so to speak. But in the print assembly process, which
dye transfer is, and so was carbo printing, and all the early color reproduction process. They would take a cyan image, lay it down on paper or glass or transparency. Then they would take a magenta image and register it and lay it down. And finally, they lay down a yellow image. And then you get all the colors. And again, you can do this on transparent support or paper, or, you know. Well, when you make the green exposure, you're putting a low contrast positive made from the red separation. And so the green is not allowed to print into a certain amount of the red area, and that depends on how strong the mask is. But if we think in terms of the subtractive process, because now we're not printing with red, green, and blue, we're printing with cyan, yellow, magenta. So according to this scheme, a low contrast positive transparency made from the red filter negative, when it's placed in register with a green filter negative, then throughout the range of reproduced tones, those areas where cyan is printed from the red filter negative, okay, a little less magenta will be printed from the green filter negative. And this happens because the available cyan dyes, in effect, contains magenta. So the contrast of this positive transparency determines how much less magenta is allowed to print through from the green filter negative. That's a convoluted way of thinking, but Albert thought of it. And so even with the other negatives, with the blue separation, you can bound a positive mask with that to address areas in the other color spectrums. I don't really want to get into that because there have been many theories where you're using 12-stage masks, 8-stage, 2-stage, but you have to address all three negatives, because once you add a mask to a separation negative, you in reality change the density range, right? That goes back to lesson 1, session 1, where I talk about paper response to density range. So what you do to one separation negative, you have to do to all three, because you need that grayscale to match. So masking gets very complicated when you're trying to address all the deficiencies in all the colors. And there's been arguments going back and forth about what is the best way to proceed, and I don't think it's ever been settled. But suffice to say that the main problems are in a green separation and a blue separation negs. The red is fairly good. The red dyes and pigments that they use are fairly good. So, but even the red separation has to be addressed. So if you have a green separation negative that gives you a density range of, let's say 2.0, and you make a mask that has a density range of 0.4, now you have a density range of 1.6, because 2.0 minus 0.4 equals 1.6. You have to make the same mask for the red separation negative. So you could make a red separation negative that has 2.0, use the same red mask just to reduce the contrast so it matches the green. So that's typically what was done when I learned dye transfer. That was what we did. The red mask was used for the red separation, but it was also used for the green. And it was used for the red just so that the grayscales would match between the red and the green. So That's why session 1 was important. Because when you get into masking, it changes the curve shape. So I wanted to mention that, even though it's hard to understand. You have to visualize it. It really is a visualization thing. It's not, the math is too convoluted. It's, and then masking is like that. You make this mask so that the second one look different, and then you throw away the first one. And sometimes you make 2 masks to make a third one, and you throw away just the first one, and depending on what you want to do. But anyway, at the risk of confusing you, I wanted to add this a little bit because I didn't really discuss enough what Albert back in 1898 stated.
Okay, one last word before I switch to going into the darkroom and showing you how I mask. Masking is basically taking an existing black and white negative. Well, let's go back to color. I came upon masking not because of color separations. That came later. In the late 70s, I was given transparencies, almost inevitably 35 millimeter transparency. Sometimes I got 4x5 and 120, but a lot of times people are shooting 35 millimeter Kodachromes out in the sun, rich colors, high contrast. And these art directors and designers, they give me a transparency. They go to the window and they hold the transparency out, like with the sun in the background. They say, well, look at all the detail here. This is what I want on the print. And when you made, especially when you made zebrachromes or type R prints, reversal prints, all that area would be plugged up. So I came across masking as a solution to enhance the contrast, to lower the contrast and try to get some detail. Because what masking does is basically is you make a black and white positive from the transparency in register. And I'll have to show you how the registration is done. But when you sandwich a black and white negative against a color positive, it lowers your density range. And so now you can give more exposure and bring out the shadow detail. That was the reason why I learned masking. In order to compete with other photo labs and show that you had something to offer that other labs may not offer, I learned masking. Now, you can imagine if you have a transparency, you had a grayscale. I should open this up again. With white to black, when you sandwich a film and make an exposure there, even though it's a low contrast, a thin negative, if you will, when you sandwich that with your transparency, you're plugging up the whites. You're going to plug up this area. This area is going to be clear on the mask. This area is clear. This area is dark. Usually a mask will stop right about here. So that gives you the ability to expose for this shadow to come out, and this won't get burned out. Well, your whites go flat. when you do that. You get this really muddy looking white. You do get more detail here, but your whites are not snappy enough in here. So you have to make a highlight mask. And the highlight mask is a high contrast mask, usually done with a litho film, Kodalith. And when you make a highlight mask, it's only dark here. And it's not so dark that it extends down here. You want the highlight mask to stop here. So only that area is blocked. Once the highlight mask is dried, you put that in combination with your transparency. With that in place, then you make your main mask. So the main mask is dark here. It probably stops here, but your main mask is clear here because it's blocking exposure. The highlight mask blocks exposure to the highlights. It allows exposure to come through where you want your detail, so it helps you dodge your detail. It's clear in the shadows so that your shadows also can come through. That's the basis of masking in a very short paragraph. That's all masking is. Now you can use filters so that when you make your mask, you can block certain colors. If you use a red filter when you make your main mask, you'll be blocking your blues and cyans. You can use orange mask to back off, which was quite common for what I often used the orange mask. I hardly ever used a red mask, red filter. Yellows, even less so. Sometimes you use green if you wanted to darken the magentas in a certain. So depending on the picture, you could use filters, but in short, masking is simply using a highlight mask, dodging the high value detail for you. Now when you make your print or your negative, because I was making color internegatives, actually I made a lot of color internegatives through masks. Then you can dodge your high value detail. Because you're using 20 seconds instead of 10, your shadows come out more. You're getting a lot more exposure in this area. You can use 10 seconds because you're dodging. The mask dodges perfectly because it's in register. And your whites come out better because your whites are getting even more exposure. They're sparkling. So you get the best of both worlds, the highlights and the shadows. And the blacks should remain black because the mask, conceivably, you're masking a contrasty original, so blacks will remain. And tricolor masking is, again, making 3 exposures with different masks in between. The trick is to keep the grayscale. And that's actually why I developed the software. Because I was doing it by hand. It took a long time, you can imagine, to get things balanced. But okay, so yeah. So I came to masking by the seat of my pants, just doing this on color transparency, which I was getting almost every day. And sometimes the mask didn't work, and I didn't quite understand why. It always worked. I mean, sometimes it didn't make the print better, but I found out that I could increase the contrast if I was given an original that was flat. I could, because I'd make the highlight mask all the way down here, and then the mask would block this and add contrast. So depending on how I made the first stage mask, the highlight mask, I could change the look of the original transparency. But that took a long time. I didn't learn that right away. And one day, it was probably about 1979, 1980, I thought, well, if I can mask transparencies and address the high value detail in an image, why can't I mask negatives and address the shadow details and dodge the shadow detail for me? And actually in combination, if I mask the transparency, made a color negative, and I masked the color negative, would I not then have even more control? And I actually started doing that, not with color, I did that with black and white. Because I had black and white negatives that I had shot over the years, and there were certain images that I liked, but I never was happy with the print. And instead of making a highlight mask, I would make a black mask, so to speak. But it's hard to separate just the black from the shadow detail, and so I had to do bleaching and so forth, which I'll go over in the darkroom. But lo and behold, it worked. So that was in the early 80s. One of the first successful images that I shot with masking in mind was when I went to New York in 1982. So yeah, I had gone to New York, came across, I was sitting at a sidewalk cafe, and my wife, my cousin, and my sister took me through Macy's. I don't know if you've ever been to Macy's in New York, but it's huge. It's like a football field. And it had like 6 floors, and we went to every floor. And they were buying things, and it was my job to carry everything. So when we finally finished shopping, I sat down at this side, and they said, "You sit here and wait, we're gonna get you coffee." So I sat there, and they went to buy me a cup of coffee. And in front of me were these 2 chairs, and it just looked right. But because it was overcast, I decided to shoot it with masking in mind. So I didn't worry about the highlights being, the high values being overexposed. I figured I would just mask it. And I shot to get the detail underneath the table. Underneath it, you can see gum and stuff underneath, and the legs of the chair were black, and I knew I could separate the legs if I gave enough exposure. And sure enough, the negative was really quite overexposed. But because I used masking, I was able to get everything, and that was my first successful use of what I knew to complete an image from beginning to end. So prior to that, all my negatives had already been shot, but now I was shooting to mask, so I shot it differently, and it worked. And so yeah, and that was 1982. I know that because my wife was pregnant with my daughter, who was born in December of 1982. Okay, so I eventually went into negative masking just because I thought, well, it should work. And indeed it did. And that's what I will be teaching in the 3rd session, is negative masking. I'm not going to go into transparency masking because I don't do that anymore. I don't have a color photo lab anymore. So, but I could do it just to make black and white negatives, and then mask the black and white negative. So quite often I did mask transparencies to make the negative, and I masked the negative, and then I made the print. And those prints always looked better than if there was no masking done at all, of course. Making negatives and transparencies is one of the most difficult things to do to make it just right. Okay, so that is the introduction to the 3rd session on film masking. And again, you don't need to understand all of this in order to do film masking, but because I'm going to go step by step now after this. but I just thought it was really, really interesting, especially you know, these guys who were so clever at figuring out this stuff for us. Okay, so after this I'll show you how to prepare a negative for masking. You have to punch it, you have to have equipment. It helps to have a densitometer. You've got to have different chemistry, different films. And another thing is diffusion. The mask is always made soft, out of focus. It helps in registering the mask to the original. So masking film is made with diffusion, but you don't have to have masking film. You can use conventional films. You just have to use a diffusion sheet, which I'll show you what that looks like too. Okay? So until we get to the next session, I'll be working on that.